All right, so hello, welcome. My name is Jessica Barnett. I am a park ranger and preparator, fossil preparator / interpreter at Petrified Forest National Park. I have a PowerPoint that I'm going to show off today. So I'm going to start with a screen share, and then once that's going, we will answer questions as you have them. So feel free to point out in the chat if you have a question, write it in. I've got David doing our monitoring of that, so he'll let me know if there are any questions. But otherwise, I'm really excited to get to know all of you and to answer any questions you might have, and to hopefully provide you with all of the knowledge that I have. Maybe not all of it, but a good chunk of it if we can manage. So let us screen share. Okay. So just out of, okay, so I think you guys are seeing my notes. Is that correct? Can I get like thumbs up from people so that I can change it so it doesn't look like that? If you're seeing the notes on the screen. I don't actually know how to change that. Okay, so I'm seeing thumbs up. You guys are seeing my notes. So I'm going to try and make it so that you don't have to read exactly what I'm writing. So give me just a moment. Okay. Follow-up question. Thumbs up if it's just the slides now. Excellent. So I'm getting a thumbs up from Jay Larson. Thank you so much. Okay, so microfossil preparation. Hello. I'm going to welcome you all to Petrified Forest National Park, where I work. That is in Arizona. We are just outside of Holbrook, so kind of central east, pretty close to the New Mexico border. We currently have a fully staffed fossil preparation lab. 2 of our positions are for museum technicians who do paleontology, but we do have 5 trained preparators on site. Our 2 technicians are Diana Boudreau and Phil Valera, and then we have our lab manager, Deb Wagner, our museum curator and collections manager, Matt Smith, and then of course me. So my job as an interpreter and preparator is to translate all the things that we see here in the park and turn them into an understandable language for the people who visit. So how does that make me a trained preparator? Excellent question. So I'm Jessica. I've been preparing fossils since about 2010. I started at the Mammoth site in South Dakota, although I was doing microfossil sorting and that sort of thing at Washington State University, where I did my undergraduate degree, and then proceeded through all these other sites. So although currently I only prep fossils 1 day a week, I have been working on and off as a preparator since 2010. I started out working in paleontology with crinoids and doing research on those, where we find them in the Salem Formation, and eventually building up on that to other vertebrate and invertebrate fossils. One of the really exciting things when I started studying crinoids is that they were only recently discovered as living animals. We thought they were totally extinct just before that, so that was pretty exciting. I kind of learned the most basic of micro preparation there, so sieving things, sorting through the material that was left behind, how to piece things together, glue them, identifying all the individual fragments, and then eventually trying to sort out what to keep or toss, the things that we don't need, lots of unidentifiable material, that sort of thing. So eventually, of course, I graduated, took an internship with the Mammoth site in South Dakota. And again, that's when I really started learning fossil preparation. I started working on the macrofossils there, and shockingly, of course, was working with macrofossils, mammoths. So that's the Mammoth site. That particular site is really easy to learn at. We were given glues, adhesives, and then of course the sediment was soft enough that we could use mostly pin vices and occasionally air scribes. After I completed my internship, I went into oil for a few years, which isn't really fossil related. But then I eventually ended up in grad school at Fort Hays State University in Kansas. While I was there, I ran the fossil preparation lab. And then in my last semester, I moved to the other Washington, not Washington State, Washington, D.C., where I interned with the Department of the Interior and volunteered with the Smithsonian. So I did get some prep experience at the Smithsonian as well. I was there for a little less than a year, and then started working seasonally with the Park Service. I started at John Day Fossil Beds, and then eventually went on to the Burke Museum at the University of Washington, shortly before COVID started, and then eventually ended up back with the Park Service at Petrified Forest, which is pretty exciting. So I'm here now. A lot of my work in those positions was more towards outreach and public interaction, but of course I love working at all of those places, and I've got to work with such amazing people at all of those places as well. So again, why me? How is that important for me to work with microfossils? I started my work with those crinoids, and then I also work with microfossils here at Petrified Forest. So I get asked a lot, what even is a microfossil? I mean, it's exactly what it sounds like, teeny tiny fossils. Generally it's thought of as something best observed under a microscope. Almost always there's some sort of chemical preparation that goes with it. But we also use really fine tools, things like pin vices. And if you have really stubborn matrix, something like an air abrader or an air scribe. So this definition is different over the years. You know, it used to be just smallish things, maybe an inch or so in length, whereas now we're thinking millimeter to sub-millimeter. A lot of the material we work with is pollen, plankton, teeth or jaws, and things like protists, which of course are some of our oldest fossils that we find in the world are microfossils. But again, since we're the Society of Vertebrate Paleontology, I'm mostly going to be talking about vertebrate materials, so teeth and jaws, that sort of thing. So a lot of the research we do here at Petrified Forest is oriented towards the micro, things you see under a microscope and what you would really notice just by walking around. 4 of our 5 most recent species are microfossils and were discovered while we were sorting through sediments. Hopefully, some of you got the opportunity to chat with either Dr. Adam Marsh or Dr. Ben Clipman, who do their research here at the park. Dr. Marsh is our primary paleontologist here in the park, and got one of the fun Fungus Burma stickers. So I'm going to talk about that in a minute, but it looks like this if I can make it focus. There we go. So it's a holographic sticker. They're very cool. So for those of you who are in person, perhaps you managed to grab one of those stickers. This funky worm is very small. Its teeth are sub-millimeter, although its jaw is a little bit bigger than that. Through a lot of painstaking sorting, astute attention to detail, and a lot of people who are much smarter than me, we found a number of new species that in the past people have not even thought to look for. I'm sure all of you know that traditionally paleontologists have looked for the animals that are considered more charismatic. So often that means large or pointy teeth. Because of that, most, if not nearly all, small fossils had been missed. I think from my perspective, the saddest part is that these teeny tiny fossils are found in almost every age since life began. We have them in the Precambrian all the way until the Holocene. But we missed them for a really long time. They were just completely missed in the fossil record. So really quickly, I'm going to showcase some of the super cool fossils, microfossils we found here at Petrified Forest. I'm going in order of when it was published. So 3 years ago, we had Cataigodon, which is called thunderstorm tooth. That's what it translates to. Vanitas is blue. But so Cataigodon is a small mammal relative, first published in 2020. As you can see, new fossil species 2020. The jaw fragment was about 6 millimeters at its widest, so kind of big enough to see with the naked eye. But this was discovered during our screen washing process. It's definitely smaller than is feasible to study with the naked eye. This specimen in particular was micro CT scanned. That's such an important thing to consider when you're doing microfossils, when you're doing micro preparation, is what the next step is after you're done preparing a fossil. It's really easy to damage or scrape up a fossil during micro prep, and so you have to be super careful about that. This one in particular was prepared with pin vices on a carbide needle and then stabilized with Buvar B76 in acetone. The next fossil is Skybalonyx scepter, which is the digging dung claw. It's not as exciting to talk about, but it comes from the Blue Mesa as well. This Skybalonyx fossil, even though it's much larger than Cataigodons, was discovered during our micro prep process. So it was found during in screen wash material that was collected from the Blue Mesa. A lot of our fossils come from that area. It's a little bit bigger than 2 centimeters at its largest length, and it's the digging claw of a trypanosaur. So there are 4 species of trypanosaurs in the Chile Formation. This is just the most recent of them. After screen washing, this specimen was also prepared using a pin vise. And then I don't actually have any notes on what it was stabilized with, but it's probably either a paraloid or butyl. Those are our more common stabilizers that we use here in the park. And then for this little guy, its final step was photogrammetry. So if you're not familiar with photogrammetry, it's where you use a lot of photos stacked on top of each other so you can get a clear view through various fields of depth. And so it allows a really small fossil to have incredibly clear pictures of them. So definitely check out photogrammetry if that's something you work with. Then we have Trilophosaurus phasmolophus. This is the most ridiculous name I've ever heard. So Trilophosaurus, if you are good with Greek and Latin, is the 3-loafed lizard. It talks about its teeth and how the teeth have 3 loaves on them. But if you look at the picture, there are only 2 loaves. So that's why it's called phasmolophus, because it's got a ghost crest. So a ghost loaf. It's missing one of its 3 loaves. I am not a researcher, so don't ask me why it was named that. Why it's a trilophosaur. But so this one as well, carbide needle and a pin vise. And then the fractures were repaired and consolidated with paraloid B72. And then it was also photogrammetrically captured, so with a normal digital camera. This is one I find very interesting, which we can talk about later if you have questions. Our 4th species here is Puercosuchus treverorum. That's too many R's. So Puercosuchus is one of our more well-known species, primarily because this is one of the 5 specimens that wasn't found during screen washing. We do find the individual teeth, however, when we are screen washing, but most of this was fragments that were visible. Mostly I wanted to just show it off because it's a cool fossil, and it's one of the 5 that we found that wasn't screen washed. And then we have Fungus vermis. So this is our most recent species. This publication came out in January. This is the funky worm. So as I showed our sticker, this is our Sicilian. This Sicilian is in fact the oldest Sicilian found in the world. It's 35 million years older than the next oldest, which is pretty exciting. This little jaw was collected during screen washing, cleaned with a pin vise, and then glued together with Butyl B76. So how are microfossils different to microfossils different from macrofossils? As the name sort of implies, macrofossils are bigger. Things like the Trypanosaur claw was 2 centimeters in length, whereas something like the Trilophosaur is a few millimeters. Generally, it's defined as something that you use microfossil techniques to discover. For me, that means anything that we find during screen washing, I consider a microfossil. It's not something that we see when we're looking around on the ground, and it's often only discovered because we take the time to break down the matrix and then pick through whatever is left behind. So what makes a microfossil are the techniques used to prepare it. Some people disagree on what that definition is, but I think for vertebrates, that's a pretty good classification of what a microfossil is. When we're talking about invertebrates, things like dinoflagellates, peripera, anything else that's really, really tiny, very, very small, that you need like a scanning electron microscope to really understand. Then we're talking about different techniques for that. So invertebrates have to be much, much smaller, under a millimeter to even 1,000th of a millimeter. That would be microfossils in the invertebrate world. But again, so for vertebrates, we're talking primarily millimeter-ish size jaws and teeth. So of course we can use the same techniques that we for microfossils as macrofossils, but more often than not, we're cleaning the larger fossils with mechanical tools, things like air scribes, air abraders, and pin vices if it's really delicate. It's important to recognize that when you're preparing things mechanically, the composition of the materials isn't quite as important as the hardness of it. So instead of asking what is a microfossil made of, or what is a fossil made of, we're asking how hard is that material. So is our fossil harder than the matrix it's in? Can it withstand the particular teeth that we're using? How resilient is it? So with microfossils, that's different. You really need to understand the composition of both the fossil and the matrix to get a strong understanding of how to prepare those microfossils. So how does one prepare a microfossil? Finer tools and chemicals. So I don't want to spend a lot of time talking about these sorts of compositions because these are important for microfossils, and again, not vertebrates so much. So really quickly here, if you're trying to use these materials, I've put some great resources on there. Feel free to screen grab it or look into those articles that will help you to prepare those invertebrate fossils. But for vertebrates, we're mostly going to be talking about using water as a chemical instead of using these water and hydrogen peroxide. So this is a list of resources where you can find SOPs for each of the different matrices and rock combinations. For chemical preparation in particular, you have to understand what your fossil is so that you don't accidentally dissolve it away. So if you have a matrix and fossil that are siliceous, for example, you're not really going to prepare with an acetic acid, which is generally considered a weak acid like vinegar. So chemical preparation can be used in various concentrations. Often we use water, hydrogen peroxide, acetic acid, formic acid, hydrochloric acid, hydrofluoric. I don't know if I said that. Anyways, sulfuric acid, nitric acid. There's a bunch of acids that you can use to remove that matrix. For microfossils specifically, once a chemical bath soaks the appropriate amount of time to disaggregate the matrix, it can be rinsed and buffered, then sieved and sorted, much like we do with our other fossils. So for vertebrate fossils, the most important thing is to simplify the process for your preparators or interns and students, since most researchers aren't picking hundreds of pounds of matrix, unlike the rest of us. Here at Petrified Forest, because we have a fairly soft bentonite clay, composing the majority of the matrix we sort through, we use water to break it down, which doesn't tend to damage our fossils. It can, if it's within cracks, expand those cracks. Of course, our bentonite clay is an expanding clay. And then water won't remove all of the matrix, but as you may have noticed when I was discussing the different fossils we find here, we often use pin vices to remove what's left. And then our favorite consolidants tend to be paraloid B72, bufar B76, typically dissolved in acetone. Of course, you can use other solvents, but that's what we use most often here. I want everyone to keep in mind, though, that paraloid and bufar won't always work, specifically with acetone, doesn't always work with microfossils because of the rate at which acetone evaporates. It can bubble or shift the fragments. It's degassing, and that can reduce the quality of the joint. It can spread it apart. It can get the job done, but it's not the ideal chemical to use to switch those around. So how's a microfossil different from a macrofossil? That's not really. So fossils are fossils, and the techniques that we use to prepare them are often incredibly similar, whether it's super teeny tiny or really, really big. But again, the really important difference is microfossils are typically removed from the matrix chemically before that manual preparation begins. So first step, screen washing. But what makes it so difficult to prepare microfossils compared to macrofossils? We use different chemicals, different techniques, different tools. And then the important thing, right, is it's easier to mess up. We're really busy trying to make sure that our fossils are as well preserved as possible, right? Our goal as museum professionals is to preserve things in perpetuity for as long as possible. And so often we are looking for the best ways to preserve the fossil, whether or not you have that hard fossil material. It's also harder to fix. In your solvents, your acetone solvent can often evaporate too quickly to make those joins really, really tight. And so sometimes you have to choose something else that will make a better join. So I have a couple little videos. This question, what sort of animals are microfossils? Mentioned teeth and jaws, but of course that's not the only thing. So I have this quick little video. U.S. government property, because we were Park Service. Ta-da, tiny little fossil embedded in clay. So we have our pin vise, and then this is the jaw of a bowfin fish. So often our fish are considered microfossils. They disassemble pretty easily, so all of their constituent parts tend to spread around. We get isolated teeth, jaw fragments, ribs, scales. Don't know why it took me so long to think of the word scales. And little bits and pieces. So as things disaggregate, those individual parts can be considered microfossils, again, because we don't usually find them unless we're screen washing. Although this is a fairly big piece, this was screen washed. So this is a fragment that we pulled from screen washed sediment, and that little piece was found inside of it. So teeth, so we have our tiny mammal fossils and mammal ancestors, jaws of really small critters, things like salamanders, frogs, lots of amphibians in general, reptiles, we get a lot of reptiles out here, and again, pretty much anything that's just small, that's what are within our microfossils. So when you're preparing fossils, what do you need? I have this really interesting picture that I wanted to show off because microfossils can be really difficult to work with. This is a small little rig here that was developed by Ben Kligman, the paleontologist who comes out here and researches with us. He just got his PhD, so great job, Ben. We're very proud of him. And Matt Smith, who is our collections manager / curator. This is 3 pins attached to a block. All of those twist and swivel, and the whole thing can be shifted around. We use this mount for gluing the pieces together of really small fossils. So those needles are carbide rods. I believe they're 0.5 millimeter, so fairly small. And then right on the tip of them, depending on the fossil, can be either, we use paraloid for that, and then carbowax. So we use those. Carbowax is pretty easily melted, fairly soft. And then the glass temperature of paraloid is also fairly low, so we can warm it up, or we can put a drop of acetone on it, and that drop of acetone will soften it enough that we can glue the specimen on it to adjust its fragments. And so by rotating that block around, we can really glue things together. So that's kind of a cool little invention that we put together here at the park. So other tools you might need though, sieves. So here at the park, again, we use water as our primary way of our chemical preparation. You can also use a deflocculant when you're wet sieving. So of course, wet sieving is typically going to be in water to start with, although again, you can break it down with other chemicals if you're having a harder time. Hydrogen peroxide is another really common one used in things like clays. We don't use a lot of deflocculant here, but I know in other places, when I was at the Burke Museum, we used soap in order to help really disaggregate that matrix and eventually break it down into smaller pieces so that our fossils can be separated out fairly easily. And then that bucket and water are incredibly useful for that. The most important thing once you have your sediment disaggregated is your stereoscopic microscope. It's pretty difficult to use like a single vision microscope. You really need that 3-dimensionality. So the stereoscopic portion of it is kind of essential. If you're wanting to do photogrammetry or just generally take pictures of your tiny little fossils, having a camera and an adapter that works with your microscope is also incredibly important. That adjustable directional light source will help you find things as you rotate your fossils, as you're sorting through them. Your tweezers so that you can pick up those tiny little pieces without losing them, paint brushes to kind of get through them, and then grid paper, which will help you as you go through the microscope to see all the individual sections. It'll help you sort through them a little bit easier. And then adhesives. So I know I've mentioned these before, but we use bufar and paraloid. And then if you need a glue that doesn't have an evaporation stage, a degassing stage, then this is when I would suggest cyanoacrylates. In just about any other circumstance, as a preparator, I don't recommend cyanoacrylates. It's important to have things that are reversible so that you can fix things or fit in new pieces if you find new pieces where they fit. However, these super tiny fossils can be really difficult to work with if they're not really tight joins. And to make those tight joins without the degassing, cyanoacrylates are really the only way to go. So if you're struggling to get those really tight joins as you're putting things together, then I would consider switching to a cyanoacrylate. And then for storage, once you have sorted things, you can use vials, small boxes, and then FF foam, and not strictly necessary, but at least for us, that's something that we use for our kind of medium-sized small microfossils. So here's a quick video of our sitting process. So we have a large bucket filled with water, and then this is Dr. Adam Marsh doing the initial wet sieving with a big tray. This is just water. Again, I've definitely seen people use hydrogen peroxide, dilute solutions of hydrogen peroxide to mostly create bubbles that are really going to get into the cracks and little spaces to help, again, deflocculate, to break up those pieces so that the matrix is more easily removed from those fossil materials. In our case, with those clays, they come off pretty easily with water. After you wet sieve, if that's something that you're doing, you'll want to dry sieve. So we have a series of sieves starting at, of course, our larger squares down into this finer meshes at the bottom. And then you can sort through those with the tweezers or brushes. And then if they need to be further prepared, pin dices. Apparently I have two of those. What is going on? I don't know why I have two of these videos. Apologies. So then we have microscopy. So you'll want to use a microscope for any kind of microfossil sorting. This is kind of an example of the difference in what we see. So we have our lovely 3D printed model of a fossil that was micro CT scanned. And that comes from our jaw just right over here. So less than a centimeter in length, the original fossil less than a centimeter in length, transformed into our massive 3D print, which is here. This is kind of where I really want people to consider what materials, what chemicals they're using when they're preparing fossils. For this one in particular, there wasn't a lot of chemical prep that we did this besides the original screen washing. This one was prepared with a pin vise. And so all of those fine details, the foramen along the very front of the jaw there, and all of the individual teeth were preserved because we didn't use any kind of chemical preparation, which helped to keep from dissolving those fine details. But you can also see pretty big fractures in it. So in the case of this particular specimen, we decided it was better suited and more stable staying in the rock than removing it. So much like a macro fossil, you have to figure out when is the appropriate time to stop preparing it. In this case, it was decided that only half of it needed to be exposed, and then the micro CT scan would do a good enough job of getting the extra data that was needed. That's where it was stopped. And so we do have this big fracture throughout the front portion of the jaw there. Oh my gosh, apparently I doubled up all the slides. So this is kind of a video to showcase where we repaired this. This is that same specimen. Just give it a second. Zooms in very slowly, I apologize for that. A lot slower than I remembered. It's taken a very long time. So we have that big fracture that you can see in the micro CT scan. So that runs just right here on the right portion there. And you can see how small that is, how if we'd continued preparation of this fossil along the backside, there wouldn't be any support to it. It's a very narrow piece. It's about a 0.5 millimeter in thickness. And because it's so fragile, it just became clear pretty quickly that it wasn't the appropriate choice to continue preparing it. And so it is still in that matrix. But the other thing I want to point out is the glue down here. So there were 3 fragments. This was broken into 3 separate fragments through the middle along that sort of Z-shaped fracture to the right. And so you have those 3 sections that were glued together. So there's a bit of a sheen in that lower portion of the jaw matrix down here. Sorry, lower portion of the matrix, not the jaw. That is, again, Butvar B76. So I want you to just recall back to the little pin jig, which allows us to hold those pieces firmly together during that adhesion process. So we were able to take that central piece, the smaller of the fragments, this one right here in the center, adhere it to, most of the glue is actually left over from when it was stuck to it. We used paralloid B76 to stick it to that central pin. Let me go back really quick so I can showcase that. There we go. So that central pin at the bottom, that's what it was glued to. And then the other 2 fragments were stuck to these side pins that stuck out. And then those pins held it tight together so that as the acetone evaporated out, it was able to be held in place. So something like this rig here has been incredibly useful for us as a whole. It's probably not great for every location that's trying to do prep, but it's been really, really wonderful for us. It's very, very good for us. Okay, skip through these guys. Okay, and then we have storage, right? So sort of the last step for any fossil after it's prepared is storage. How do we protect it in the long run? I do sort of consider this part of preparation, so that's kind of why it's on here. We really like tiny vials, but there are, of course, other ways to store them. I like this one too. This one's one of my favorites. So take a look at this, a small archival box with ethafoam inside of it, and then a little piece of string sticking up. So you may notice there's a tag on it. It says pull string to lift, and we will play that video. Ooh, more ethafoam. How exciting. Ta-da! Our lovely little jaw inside. So that's another way you can potentially store your tiny little fossils that we quite like. So it's safe for the fossil, easy to pick up, and just a fun little compartment. I think it's really cute. So I like it a lot. So another example of some of what you can kind of expect when you're doing microfossils. This is a big fossil, but it's the same sort of process, right? As I mentioned before, microfossil preparation and macrofossil preparation are fairly similar. It's really just the scale that you're working at. So this is, of course, air scribing. So if you are familiar with air scribing, this is very familiar. This is, I believe, a bit of metoposaur that we're working on, which is an amphibian. You have some that are quite small. I believe this is one of the smaller metoposaurs. Apachosaurus is around 2 feet in length. Sorry, I had to visualize it with my fingers. About 2 feet in length, which is much smaller than some of our larger metoposaurs. You can, of course, use air scribes and pin vices as you're working on microfossils. You really just have to consider the sturdiness of your fossils. So the strength of it, can it withstand a particular preparation technique? That's where that hardness becomes important. So if you have a really hard microfossil, like our macrofossil here that we're looking at, then it's absolutely possible to use our macrofossil techniques, things like air abrasion and air scribing, and those big pin vices. I think this video has like another minute on it, so we're just gonna kind of pause that there. Because it's the same, right? So it's the same as small fossils and big ones. Of course, macrofossils are not, or microfossils are not just vertebrates. Things you need to be considering as you're preparing these vertebrate fossils and other fossils is that original material. Is it a plant? Is it an invertebrate? What kind of matrix is holding it together? Is it well cemented or not? Is the fossil itself well permineralized? Those all are going to make a difference. They're going to impact how we prepare things. Our plants often flake apart, and so if we're wanting to preserve particular things like cellular structure, you can do that in how you prepare it. You can use hydrofluoric acid, which will preserve some of the cellular structure if you have like a carbonized specimen. For invertebrates, I know I discussed that a little bit earlier, but knowing what the material is made of, if it's siliceous, if it's calcareous, having that in your mind and understanding where or how to remove the matrix without damaging the fossil is incredibly important. And then, is your sediment, is the matrix well cemented or not? If you have a microfossil and it's got a really well cemented matrix, perhaps you will need to disaggregate it in the way of chemicals that aren't necessarily just water like we use here. And then the strength of the fossil itself, right? The permineralization, how well is your material fossilized in the first place? So what I'm saying is that it's tedious. Cleaning microfossils is hard. It takes a long time. You have to go a lot slower than you do with a big fossil. If you damage a small fossil, you are much more likely to destroy it rather than just break it, right? So if you have an air scribe and you scribe into a microfossil, it's gone, it's destroyed, it's not coming back. Unlike something like a macrofossil, if you have a sauropod humerus and you accidentally hit it with your air scribe, you're making a tiny little pit. It's a very different experience. So like all fossil preparation, it takes patience. You have to be patient when you're doing microfossil preparation. You have to give so much attention to the detail, put so much care into it. And I like to remind folks of the saying, you can get it done fast or you can get it done well. You can't do both, right? So do well, do good, maintain your fossils in the best way that you can. And if you have to use any chemicals or aggressive techniques, make sure you're documenting that. So document. So I tell my education students all the time. And so this last part is questions. And in exchange, I shared with you a photo of my really adorable puppy, Archie. So questions, discussion. What do you want to talk about?
It looks like you got a couple in the chat, Jess. One from a Patrick Wilson. On your storage boxes, do you put the catalog number on the outside or just the inside?
Oh, that's such a good question. So I switched to this thing, but I actually meant to go backwards. Let me go back to our box. So we have it on the, this is kind of just a demonstration of it, but so this tag that's on the top, also, depending on the specimen, we'll have the information on the outside as well, but we have labels on the shelves. So we have a list of like all of the fossils and a map of what's in the tray. And so we have the individual specimens on those trays. And so we have a map of where all the fossils are in the tray. Does that answer your question? I hope. So I guess the answer is no, not really. So we can add the label onto the top, but typically we don't.
You have one from another Fort Hays State standout, Kenshu Shimada. I presume the porosity of bones has to do a lot with decision making. But what's the concentration of consolidant, e.g. paraloid B72, typically used for microfossils? And how do you prevent them from sticking to the substrate?
Oh, that is a fun question. Okay, so interestingly, at petrified, so okay, I'm going to go backwards just a second and I'm going to restart that thought in a moment. But yes, absolutely, the porosity of the bones makes a huge difference, primarily because it's that it determines the strength of the material, right? So for our fossils, for example, we have pretty well consolidated, siliceous, very silica heavy fossils. And so they're sturdy, right? So they fracture, but they don't really explode. I'm trying to think of the better way to describe it. But so with our bentonite clay, for example, as it expands, it tends to expand cracks. It's not really into the pores of our bones. So when it gets wet, it doesn't like, it just breaks those cracks further apart. However, if you do have a fossil that's very porous and that clay gets into there, when you get it wet, it's not going to break those cracks. It's going to expand and explode your fossils, which is a terrible idea, right? You don't want to destroy your fossils. And so in those sorts of scenarios, you would definitely want to consider whether that chemical preparation is even appropriate, because it might be best to just use tools, use hand tools and mechanical preparation for something like that. But if your matrix is not a bentonite expanding clay, that's not as much of an issue. So you can use things like hydrogen peroxide and water, or those acids to really start dissolving that cemented matrix away if it's well cemented. As for the consolidant and the percentage of them, so interestingly, we don't actually document that in the same sort of way as other museums. I've definitely seen a lot of people say this is this consolidant in this much acetone, weight by volume or by weight, or however you're doing that concentration. We tend to think of it in viscosity. So we're looking a lot at whether it needs to penetrate into the bone. So if you have a very porous bone, do we need to stabilize it and penetrate in? And so if that's the case, we're using very thin consolidants, and we're allowing it to soak in. And again, that will just take time, letting it absorb into it. And then if we're adhering it, we're using a thicker, more viscous solution. So it's not as important to us here to have the exact percentage, weight by volume, or anything else, because that's going to change over time as well as your solvent evaporates away. And so we don't really look at it in that way so much as, is it going to get the job done? Is it sticky enough? Is there enough of the plastic material dissolved into it to hold that join together? And sort of what's the thinnest we can get away with without the specimen falling apart. And so we tend to start with a really thin, not super viscous consolidant, and then as necessary move on to more thick, more viscous consolidants. Hopefully that sort of answers your question. And what I'm going to do is, there we go, pull up the chat so that I can see it specifically. Okay. Yeah, and how do we prevent it from sticking to the substrate or the matrix? You really can't, right? So we allow it to stick initially, and then if it needs to be removed, we can go through additional processes to remove it from that matrix. But it's going to stick pretty much no matter what you do. And so if we need to remove those extra layers, whether it's because the specimen is going on display or we need to repair a join or something like that, then we would use acetone to soften up that glue and then remove it. If we're using something like super glue, which again, our goal is to not use cyanoacrylates if we can at all manage it, which is why we have our little pin rig. I'm sure it has a name, but all I know is a pin rig, which is kind of a weird way to describe it. But so we try pretty hard not to use cyanoacrylates so that we can have that reversible option, and then we just use pin vices to physically manually remove that extra material that might be stuck to our fossils. Once you have a cyanoacrylate, you really have to go through pretty aggressive, hard techniques to remove that matrix, and that's really kind of what we're trying to avoid. So we don't often use cyanoacrylates if we can avoid it, but preventing them from sticking is pretty tough. So as much as we'd like to, we kind of very finely apply it using eyedroppers and pins. So we'll use needles to just pick up a tiny bit of adhesive, and then we'll put it in little places. So we use less, I guess, is kind of the answer to that, is how do you prevent it from sticking, is just use less. And then I'm also seeing kind of a similar question, and do you have a recommendation ratio of butyl to acetone in using it as a stabilizer? Another option instead of acetone is slower evaporating solvents. So you can dissolve it in lots of alcohols. You can dissolve plastics in lots of acetal alcohols, like ethanol. Ethanol is a slower evaporant. is that the right word? Evaporator, I don't know. And so you can choose what solvent you use as a way to do that. But again, for ratio, it's about thinness versus thickness. And for our microfossils, we want it to evaporate a little bit slower. So we tend to go a little bit thicker and then apply it using needles and pins, that sort of thing. Somewhat similar to my previous question. Oop, okay. I was like, hopefully that answered it. God, thank you. So thank you, Rebecca. Okay. Optimal concentration of hydrogen peroxide for screen washing straight out of the container, or do you dilute it with water significantly? So this is probably a better question for places. I know Gray Fossil Site uses a lot of hydrogen peroxide. We don't use it very often here. So when we do, we use very dilute concentrations. We use like in the bucket that was in the video. So like, I don't know, I think that's a 20-gallon bucket with probably 10 gallons of water. It's got to be more than 10 gallons. In any case, it's a lot of water. And we use, I think, half a bottle of peroxide, but that's only for kind of the most stubborn material. I probably should have read the question out loud, seeing as the video is recorded, so I'm going to do that right now. So what is the optimal concentration of hydrogen peroxide used for screen washing straight out of the container, or do you dilute it with water significantly? So yeah, we significantly dilute it. But if you know anyone from Gray Fossil Site, they're definitely the people to ask about hydrogen peroxide use, although they mostly do kind of big macro fossils. They would definitely have a better answer to that than I have.
Jess, how would you recommend, and we're going to talk about this, I'm sure, more during the panel tomorrow, but we'll ask this here as well. For some, let's say, undergrad who's really excited about prep, I think they might want to do it as a job someday, and they come across this talk on YouTube, what would be your advice to them about kind of getting started in this and avoiding easy early mistakes?
Oh, let's see, getting started and avoiding easy mistakes. A lot of getting started in fossil preparation is finding a place that that actually has some sort of fossil preparation program. That's kind of the most important starting point. But additionally, working with people who have the experience doing fossil preparation, there's not necessarily a prep program in some places, but you have people who do fossil preparation. There's also professional societies. So we have the Association for Materials and Methods in Paleontology, AMP. That's an excellent resource for people who want to get into preparation. As I mentioned, I sort of started real fossil preparation when I began at the Mammoth site. I had an internship there in 2012, so showing my age a little bit there. That was a really fantastic start for me. But there are really great universities that have some pretty incredible preparation programs, and just some really amazing preparators to work with. Sort of the ones that come to mind, or like museums is kind of more what I'm thinking. The American Museum of Natural History, the Natural History Museum in North Carolina, in Raleigh, I think that's right. They've got great preparators there. The Smithsonian, of course, is a fantastic place if you're in DC. The University of Chicago, their museum has some really exceptional preparators there. Akiko is fantastic. If you can learn with her, you're very lucky. University of Texas at Austin has a really fantastic program. The Burke Museum at the University of Washington, really, really fantastic. The University of California at Berkeley. You've got the Natural History Museum of Los Angeles. Here at Petrified Forest, we love volunteers. So if anyone wants to come volunteer or intern with us in the summer, let me know. I'm trying to think Midwest places as well. Fort Hays State University, of course, has a really great prep lab there. Where else? There's a lot of places. If you need advice, yeah, Michigan, absolutely. Thank you. Yes, wonderful, Scott. If you're struggling to find somewhere that you can find good fossil preparation, or you need advice if you live in an area and you want to find somewhere where you can do fossil preparation, my first suggestion would be go to the local university. If there's one nearby, ask them if they do fossil preparation, if they have paleontologists there, if they have some sort of preparation. And if they don't find somewhere, ask them if they know where nearby you can learn. That's usually the best option. There's universities in every state, and most of them have some sort of fossil program somewhere. So if you can find a university or a local museum, a big museum, that's an excellent place to start as well. Oh, Denver Museum of Nature and Science, Utah, what is that one? Utah Museum of Natural History. I don't know, the one in Salt Lake City. So there's really amazing preparators all across the country. And then of course in other countries as well. If you're up in Canada, the Royal Tyrrell Museum is amazing. They've got incredible preparators. If you're in the UK, the Natural History Museum in London is a really incredible place. There's really great places globally, not just in the US, where you can learn fossil preparation. So you just gotta talk to people, ask questions. Preparators love to talk about their work. We love to chat with people about preparation, and we love to teach people. So definitely get to know. See, Rebecca said, even small schools, we have a fabulous prep lab at St. Norbert College in, please tell me I'm saying this right, De Pere, Wisconsin. Hopefully it's one of those things. Yeah, wonderful. Lots of places. So De Pere. Thank you, Rebecca. Okay, so look for whatever's nearby, and ask them. They will almost always have good suggestions for where you can learn and who you can learn from.
Thanks so much, Jess. This was really outstanding. And I'll say the folks in the audience who maybe are preparators or no preparators, I would love to do more things like what we just got from Jess, in future virtual meetings, presentations about topics like this, demos, anything involving that area where we kind of spotlight it and really present even skill building opportunities where folks are wondering, like, how do I get started with XYZ thing? They find a video from SVP. It's got a breakdown on how they can go about doing the thing that they're trying to do. So if that's something you want to see more of, speak up. Obviously with the virtual meeting, we have the opportunity to do things from a wider geographic spread and bring folks in virtually. So we really want to create those opportunities wherever possible.